Good day everyone. Welcome to another math tutorial on this channel. Today we're going to tackle about solving polynomial equations. Solutions of polynomial equations. A linear equation, also known as the first degree polynomial equation, has at most one real solution. Meaning, if our polynomial is considered as a linear, there is only one or at most one real solution for it. So now let's take, for example, the case of x minus 1 is equal to. So this equation, we can solve for the value of x by adding 1 on both sides. And we can say that the value of x is 3. So 3. So this is the only value of x that we can think of in order to satisfy this equation. We cannot we cannot we cannot get any other value of x that would equal to negative to positive 2 if we subtract it to 1. The only value is 3. Now it is a real solution because it is a real number. So by as the rule says, if it is a linear equation, then it has at most one real solution. This is a linear because the degree of this polynomial is 1. Let's take in consideration another example, x plus 3. Now to solve for the value of x or for the solution for this polynomial, we just need to subtract 3 on both sides to eliminate this positive 3 here. So we can get as x is equal to negative 3. So this is the only value, and again, it suits our definition that it has at most one real solution. Now again, another example, 2x plus 1 is equal to 0. This is kind of different because x has a coefficient of greater than 1 compared to the first and second example. Now to answer this, let's subtract 1 on both sides. So that is 2x is equal to negative 1. Then let's divide both sides by 2. And we have x is equal to negative 1 half. So this is the only value of x that would satisfy this solution. On the other hand, a quadratic equation, also known as a second degree polynomial equation, has at most two real solutions. Let's take in consideration this example, x squared minus 1. I know that this is a quadratic equation because the degree of polynomial is 2. So, and to solve for it, all we have to do is to factor this polynomial. So since this is a difference of two squares, all we have to do is to separate them and factor them in this form. If you want a tutorial on how to factor difference of two squares or factoring technique with quadratic equation, you can just I will make a video on that and I will post it here. Now, there's a rule that if a multiplied by b is equal to 0, so the value of a, if the value of a is 0, then the value of b is any value of b would pass is pass is negligible because any number you multiply to 0 is equal to 0. Same as with if b is 0. So in order for it to get the value of x here, we just need to equate both sides to 0, both factor to 0, and solve for the value of x. So as you can see, this is a quadratic equation, meaning second degree polynomial. It has two values of x or two solutions. And that is the most number of solution that it could have. Let's try another example. So to factor this, let's factor this out first. Let's equate each factor into 0. Then get the values of x. So this makes this quadratic equation, quadratic polynomial equation has two values of x or two solutions. Now, similarly, cubic equation that is third degree polynomial equation has at most three real solutions. So I think by now you could see the pattern. If it is linear, 1 at most. If it is quadratic, 2 at most. If it is cubic, 3 at most. If it is a quartic, It has 4 at most kinetic. It has 5 at most real solution. So this leads to a conclusion that if a polynomial function with a degree of n has at most n real solution, the number or the values of x or the number of x or the number of solution depends on the number of the degree of each polynomial. Here are the steps on how to find or to solve for the solution of polynomial equations. First is we need to find the degree of the polynomial equations. It shows the number of roots to solve. Just like the example a while ago, we need to find the degree of the polynomial for us to know how many real solutions we have. Second is to use rational root theorem to see the possible roots of a polynomial equations. I have a video tutorial on how to do rational root theorem. So just go to that video and recall on how to do it. But in this video, we'll also practice on how to apply it here. Next is we need to check the roots of polynomial equation using synthetic division or other methods that suits in solving the given polynomial. So we will check all the possible roots. Then we will check it one by one to know which root is good, which is the root that will satisfy our polynomial. Now let's try to answer a series of problems. In example number 1, determine the roots of this polynomial. Step 1 is to find the degree of the polynomial because it shows the numbers of roots to solve. In this case, we can see that it is written in a standard form and we can easily identify that 3 is the degree of the polynomial. This polynomial has at most 3 real solutions, meaning 3 real solutions and below. Next step 2 is use the rational root theorem to find the number of possible roots. So it's hard for us to test all the numbers, so we need to use the rational root theorems, and that gives us these numbers as our possible roots. So again, on step number 3, we will test each roots. Now let's check each roots. Let's use synthetic division. Let's get the coefficients of all the numbers. Then after that, we will test each numbers here. Okay, you could test any numbers, and your goal is to make the remainder or the last number here to become 0. If it is not 0, then cross out that number. So in this case, I will choose 1. So I'll bring down 1. 1 times 1 is 1. Combine the number, it's negative 7. 1 times negative 7 is negative 7. 19 plus negative 7 is 12. Then 1 times 12 is positive 12. Then negative 12 plus 12 is 0. So if this is 0, then 1 is a solution, or the value of our x is 1. So that's how it works. Now again, we know on our step number 1 that we have at least 3 real solutions. If you already here um, in the 3 given outcome, or we know this as a quadratic polynomial, we could just factor that quadratic polynomial. Or if you want, you could just continue using synthetic division and you will come up with a linear equation product. But in this case, I will just use it. I will just put x raised to 2 here, x raised to 1, and x raised to 0. And that, if we simplify this, we can have this. Then, if we have a quadratic, it's easy for us to factor this out. So again, remember that the factor of this are in here because these are the possible roots. So if I'm going to factor this out, I will get these factors. Now I will show you how I get this. So to factor this out, I'll just put 2 set of parentheses. I'll get the root of it. Now I will think because this is positive, I will the only signs that I need to have here are 2 same signs because 2 same signs can give me a positive product. Now it's time for me to choose whether it's 2 positive or 2 negative. Now, what's your clue? Your clue is this. This is negative, so we could choose 2 negative sign. Now, what is the factor of 12 that if we add, we get 7? So that is 3 and 4. So that is the factor of this polynomial. I will be creating videos on how to factor quadratic equation, and hope you go on that and you could learn the steps there and the techniques there. Now, if we have this, let's equate both factors into 0 and get the values of x. So we have 4 and 3. And as you can see, 4 and 3 is in here. Okay, so we have that as our solutions. So now we can say that the solution of this polynomial is 1, 3, and negative and positive 4. No, now note, the polynomial equation can also be written as like this. So this is the factored form, and this is the standard form. If you want to find the value of x, just equate each factor into 0 and find the values of x, which in this case, 1, 3, 4. Now let's check if this possible roots is a real roots of this polynomial equation. So we're about to check. We're going to check if this is a possible root or not. So how do we do that? So all we need to do is just substitute it to the values of x. And if it gives us 0, then this is a factor, or this is a root, or this is a x is equal to 0 could be a solution for this polynomial equation. Now, if you are finding hard to do this, just substitute this. The red ones are x before, and now I make it 2. Then I eliminate the exponent first by by doing this. 2 raised to 3 is 8. 2 raised to 2 is 2 raised to 2 is 4 times 2 is also 8. Then 2 times negative 5 is negative 10. Then negative 6. Then I will just simplify them and get 0. So therefore, 2 is a root. How about this one? Again, let's just substitute negative 2 on the value of x. And we can simplify it. And 6 is not equal to 0. So therefore, x is equal to negative 2 is not solution or root of this polynomial. Now next, number 3. Let's try to answer this. Let's just substitute negative 1/2. Okay, the main problem here is how to raise 1/2 into cubes. So if you're going to raise this, you're going to raise 1 into cube and you raise 2 in a cube. You could just put negative on either on the top, on the denominator, on the denominator, but not on both of them. So in this case, negative 1/2 raised to 3 is negative 1/8. Now in this case, 1/2 times 1/2 is positive 1/4. And we'll say 1/2 will stay. And if we're going to simplify it more, cancel this out, we have 4 here, so negative 1/4. 1 times 9 is 9 over 4. Then negative 1/2 of 10 is negative 5 plus 3. This one, you could simplify it. You could just make that as 8 over 4. 8 over 4 divided by 4. 8 divided by 4 is 2. And we get this. And that gives us 0 is equal to 0. Therefore, negative 1/2 is a solution or root of the polynomial. For example number 4, let's check if negative 3 is a root or not. Again, let's just substitute that to the value of x, simplify it, and we get the final as 0 is equal to 0. Then therefore, it is a solution. For our last number, let's check if positive 2 is a solution for this polynomial. Okay, so 2 raised to 4 is 16 times 2 is 32. 2 raised to 3 is 8 times 7 is 56. 2 raised to 2 is 4 times 4, 16. 2 times negative 7 is negative 14 and 6. So that's 84. So it's not equal to 0. So therefore, x is equal to 2 is not a solution or root of the polynomial. Now let's have another example. Let's go with example number 3. Find the roots of this polynomial. As you can see, this has fourth degree polynomial. So meaning it has at most 4 real roots. Now let's get its possible roots, or the number of possible roots. Okay, to get the number of possible roots, you need to know the factor of this and the factor of this. The n raised to 0 and the leading coefficient. After you get the factor of that, the factor of p is this, and the factor of q is this. Now all you have to do is to do p over q. So let's start with 1. So all of this, if you divide to 1, the answer is the same. But with 3, 1 divided by 3 is positive negative 1/3. 2 divided by 3 is positive negative 2/3. Positive negative 3 divided by positive negative 3 is 1. So no need for us to write it again. Then 4 divided by 3 is positive negative 4 over 3. 6 divided by 3 is 2, positive negative 2. And 12 divided by 3 is positive negative 4. So we now have our sets of possible roots. Again, this is not the real roots. These are the possible roots of this polynomial. Now let's check each root. So again, I will test two. It's your choice whether what possible roots you're going to test, as long as you get 0 as its remainder. Now, if it's still 4 left, just if you don't get 0, then cross out the number that you test. And after you do that, don't choose that number again and choose another number. It's trial and error. But as long as if you get a 0 at the remainder, you could say that this is a root. Then after that, you could use the remaining number, which is this, and do synthetic division again and test other numbers. Again, you can also test it again. If it is not equal to 0, then that is not a solution again. So I will test negative 2 and it becomes 0, then good for me. Then after that, if I have 3 more left here, I'll just transform it into raised to 1 here and raised to 0 here into quadratic trinomial. Then after that, I will factor it out and get the values of x as negative 3 and 1/3. So now I have 4 values of x. Now again, this polynomial equation can also be written in factored form like this. Sorry, like this. Now, there are some questions like this you will encounter. So, what are the sum of the roots of the polynomial equation of this? This is the same number. So all you have to do to answer this is to get the roots and to add it up. Then you will get the answer for this. Then what is the largest root? So meaning you could just get the root of it first. These are the answer. And check what is the largest root. The largest root is 2. Then what is the smallest root? So in this case, the smallest root is negative 3. So that's how you answer this question, this type of questions. Okay, now let's try a variety of question. Find the other roots of this polynomial if one of its roots is 5. So it's clear that a root of this polynomial is 5. So let's check that first if that is possible. Now if we try 5 here, this should be equal to 0. So if we do that, 5 times 3 is 15. Combine it, positive 14. 5 times 14 is 70. Combine it is negative 45. 5 times negative 45 is negative 225. So combine this, we have positive 28. Then 5 times 28 is positive 40. Then we get 0. So from that, we could just continue here and choose a number from the lowest unit number to get to check if it is a possible roots, if it is a real roots. Then until you got into 0, then that's the time you can say that it is a solution. So now it's in quadratic trinomial. So you could just factor this out and you get 4 over 3 and negative 7 as the values of x. So the roots of this is other than 5, the other roots of this is 1, negative 7, and negative and 4 over 3. Again, you might encounter this kind of sum, this kind of questions. Remember that 5 is a root as well because it's in the given. Then you could get the sum of the roots, get the largest roots, and get the smallest roots of this polynomial. You could answer that. Again, that's how to solve polynomial equations. On the next video, we're going to tackle on how to graph a polynomial function. So thank you for watching and I hope you like and subscribe and share this to your friend, especially the grade 10 students in the Philippines. That's all and goodbye.